Welcome to our channel. Now let us discuss the stress strain curve for steel. And that too we have different types of steels, and first let us discuss the stress strain curve for mild steel. So now coming to stress strain diagram. So whenever mild steel is subjected to UTM, obviously we are going to get the stress strain curve in this way. This is just a linear. So this curve we are going to call it as a CC. CC is nothing but characteristic curve of steel. But always we are going to consider factor of safety. So whenever I am considering factor of safety, I have to divide this value with 1.5. So Fy by 1.5. So but 1.5 is nothing but this is the factor of safety for concrete, and for steel factor of safety is going to be 1.15. So obviously the value is going to be 0.87 Fy. And here we are going to get strain values. And so on. So usually we are going to get only two curves, whereas in concrete we are going to make some assumptions, but in steel in that way we are not going to do any assumptions. And now coming to HYSD bars, and most frequently we are going to consider only HYSD bars, because mild steel is going to have less tensile strength when compared to HYSD bars. So for HYSD bars, Fe 415. So obviously Fi value is going to be 415. Again, let us draw stress strain curve for HYSD bars. For HYSD bars, the characteristic curve Fy is going to be in this way. Here Fy is 415. And one more thing is that we can calculate the Young's modulus of steel. Always Young's modulus of steel is 2 into 10 power 5 Newton per mm square. So our ultimate aim is to calculate the strain in steel. So here the strain in steel, always we know that according to Hooke's law, stress is proportional to strain. So when stress is proportional to strain, stress is proportional to strain. So this proportionality constant we are going to replace it with E, that is nothing but, and this way we are going to consider. So obviously I have to know the strain in steel. So strain in steel is nothing but sigma S by capital E. So from this I have written the value as sigma S by E. So sigma S is nothing but stress in steel. Therefore epsilon S, that is nothing but strain in steel. Already we have calculated the stress in steel as Fy by 1.15, which is equal to 0.87 Fy. So 0.87 Fy by E. I already said that Young's modulus of steel is nothing but 2 into 10 power 5. So therefore this is going to be the ultimate strain in steel for Fe 250. So in the same way we are going to draw stress strain curve for 415. For 415 also we have to draw a curve, and most frequently we are going to use this 415 in the construction of buildings. So as per IS code, always we have to remember one point. Stress in HYSD bars So as per IS code, always stress in H by SG bars. It's going to have a proof strain of 0.002. So you'll be finding this statement in IS 456. Again we have to, this is the characteristic curve, but always we are going to consider curve only for factor of safety. So whenever I am considering factor of safety, I have to divide this value with 1.15. So always HYSG bar is going to have a proof strain of 0.002, and from this point onwards, this is similar to, this line is similar to stress strain curve in terms of Fe 250. So again I am redrawing this graph. This will have a proof strain of 0.002. So this line is similar to strain curve or stress strain curve in terms of Fe 250. So obviously this value or this line is going to represent stress strain curve for Fe 250. So obviously this value is equal to 0.87 F5 by ES or Young's modulus of steel. So therefore entire strain in this part represents entire strain in Fe 415, that is equal to 0.002 plus 0.87 F5 by ES. So in this way we are going to consider the strain for Fe 415, and remaining everything is going to be similar as of Fe 250. So the only thing is that you have to understand this graph. So obviously at last I conclude that this is the curve for Fe 415, stress strain curve of Fe 415. So till here we are going to have a proof strain of 0.002, and thereafter this actually looks like a stress strain curve for mild steel. So already stress strain curve for mild steel is going to have certain value, that is nothing but 0.87587 F5 by ES. So this entire thing is going to represent strain for steel. So which is nothing but addition of these two values, that is nothing but 0.002 plus 0.87 F5 by ES. So this is the ultimate strain for steel, and all these values we are going to consider in the stress strain curve of a beam. So if I know all these values, then only we can draw stress strain curve for a beam. So if you like my video, please share, subscribe. Thank you.